Okay, so this is worksheet from Friday that I'm going to go over. It's going to be kind of short since you guys haven't talked about a lot since the last exam, but we can get started. So number 1 says this reaction here is at equilibrium. If we add CO2 to the flask, will the forward reaction or backward reaction be favored? So you can tell by these reversible arrows, there's one reaction that's happening this way. It's going from CaCO3 to calcium oxide and CO2. That's the forward reaction. It's going forward. There's also a backwards reaction. So there's one that's breaking this molecule into these two molecules. There's another reaction that's combining these two into this molecule. That is the backwards reaction. So right now it's at equilibrium. Both reactions are happening at the same rate. But if we add CO2, if we add more of this one to the flask, the question is asking, is this reaction going to be happening more often, or is this reaction going to be happening more often? So I kind of think of it as like a seesaw almost. If we draw kind of like a little seesaw structure, if you add more weight onto this side of the seesaw, this side is gonna go up, right? If we add a person over here, it will then look like this. So if we add more molecules to this side, got not just one, but a bunch now. If we add more weight to this side will go up. So there's going to be more calcium carbonate produced. Which means that if there's more calcium carbonate produced, this is going to be the product side, which means the reaction is going to the left. And that is the backwards reaction. So that side is going to be favored. Erase all this. Okay. I'm looking at number 2. It says a bowl of spaghetti contains... a bowl of spaghetti contains 9 grams of fat, 25 grams of carbohydrate, 12 grams of protein. How many kilocalories of energy does the cheeseburger contain? So, I'm not sure if you'll have this on an exam, but these are the values for the kilocalories per gram for each type of food. So all we have to do here is just multiply. So the bowl of spaghetti contains 9 grams of fat. You can just write this out. Okay, 9 grams of fat times 9 kilocalories per gram. Let me space this out. Okay, so that's the fat, and then carbohydrates is, we have 25 grams of that. Let's multiply times 4 kilocalories per gram plus 12 grams of protein times 4 kilocalories per gram. So all of these grams will cancel. And then all we have to do is multiply. So it's going to be 9 times 9 plus 25 times 4 plus 12 times 4. And that will equal 229 kilocalories. So at the end of this one, we're going to report the answer to 2 sig figs. So basically we can just round up to the next number. So we're at 229. It's going to become 230. Okay. Moving on to number 3. It says, are the following reactions endothermic or exothermic? So if we remember, endothermic means, absorbing heat. Exothermic is releasing heat. And I always remember this one by, I just think exothermic sounds like exit. So the heat is exiting or being released. Okay. So looking at these reactions that we have, these ones are not reversible. They're only going this way. So we don't have to worry about the backwards reaction. So in this one, the heat is on the product side. So we're producing heat. In the reaction, there's heat being produced, which means it's going out into the atmosphere. It's going to be very hot around the reaction. So if we're producing heat, that's going to be exothermic. Okay, and then the second one, the heat is on the product side. So that means that we're using heat in the reaction. There's heat going into the reaction. So it's going to be cold around the atmosphere because the heat is leaving the surroundings and going into the reaction. So because the heat is on the reactant side, it's going to be endothermic. Okay, and then looking at number 4, this one's another reversible one. It says, is the forward or backward reaction endothermic? So I think it will be easier if we write out both of them. So the forward reaction looks like this. Backwards reaction looks like this. Okay, so this one, it doesn't explicitly say if heat is a product or a reactant. So we can look at what's happening in the reaction. So in the forward reaction, there's two molecules that are coming together to form a new molecule. So there's a bond being formed. And if we look up at number 3, at this one, the same thing is happening. There's two molecules coming together to form a product. So there's a new bond being formed. That one is exothermic. Oops. And then in the second one, in the backwards reaction, we're starting with the molecule and it's being broken into two separate pieces. So there's a bond being broken. And in order to break a bond, that requires a lot of energy. So a lot of energy is going to go into that process, like it did up here. We had to add energy. We had to add this heat in order to get this ammonium nitrate to break into those two separate ions. So that's going to be endothermic. So even if it doesn't tell you where the heat is specifically, you can infer by what's happening in the reaction. Okay, that's all I had for this worksheet. If you have any questions, please email me, and I'll see you on Monday.